what are the problems that I can find on the field when it's time to install an NKV. NKV is a simple pump, let's say it's a common technology that most of the people know. Is not that much different from other pumps that are there in the market. So it's always better to keep in mind just few advices that are almost valid for all types of pump. So the first problem to avoid, and is written big in here, is do not run dry. That means do not start the pump without water on it. Why? Because if the pump rotates and there is no water, actually water works also as a media for the pump, but is also lubricating liquid that keep the mechanical seal wetted. So if there is no water in the pump, mechanical seal actually friction increases, it generates a lot of heat, and the mechanical seal get burnt to work without water. So first thing to check is water inside. If there is not, you can instantly have a failure of mechanical seal, and you can see actually the two components get completely burnt. You can see the mark of this. How to avoid the pump to run dry? Of course, you have to fill the pump with water before operating the pump. The best way to do is opening a tap in the suction. In case of flooded suction, the water will go and fill the pump automatically. Then we do a little bit of air venting from the top of it, just to get rid of the air, and the pump will be wetted and ready to go. If the pump is in suction lift, that is not really suggested installation layout. We always prefer to have the pump in flooded suction, but if it is in suction lift, actually taking the water from a level that is below the pump, we have to make sure that the pipeline also on the delivery is filled with water. So yeah, you have to find a way to get water into the pump before starting. Another problem to avoid is the electric connection on the terminal box. This pump, as we said, is 3 phases, so it accepted a voltage that is 230 on the copper winding. To have the 230 voltage from 3-phase power that is usually supplied as 400 volts, we need a delta connection into the terminal board. Delta connection is already there, put by factory. But if you change that because you think that you need a star connection, you might get an overvoltage on the copper winding and you might burn out the motor. That has happened to us, to some of our customers, and that's not good. We have to be very careful. One mistake costs you the total motor of the pump. Another thing to be careful when you install an NKV is about the electrical connection to the terminal box. This pump always have a 3-phase motor that require 400 volts as a nominal tension. So usually the 3-phase power is providing 400 volts as well. So 400 required, 400 given. The connection in here must be a delta connection. You only change into a star connection when you have a 680 voltage from the power line, but the pump still requires 400. So when you want to reduce the power from 680 to 400, then you change it into star. But that would be really the 1% of case. The pump is provided with a delta connection inside. Don't change it unless necessary, and everything will go smooth for you. The third thing to be quite careful when you install the pump is to follow the arrows, the indication that are given into the pumps. So, for example, inlet and outlet, they look quite similar, they look actually the same, but the pump is telling us which one is the inlet and which one is the outlet. You have to follow this arrow that is on the basement. There are 2 arrows on the 2 sides of the base that tell me this direction. So actually this is the direction of the flow from here, that is the inlet, to here, that is the outlet. And another direction that I have to care about is the sense of rotation of the shaft. You know that in three-phases motor, accordingly to how we wire the three phases on the terminal box, we can have the right rotation or the wrong rotation for the shaft. So here on the metal support that we have on top of the pump, there is the indication that tells us which is the rotation direction that we want. So we have one arrow in this direction, another arrow on the other side on that direction. These two directions together are telling us that this is the rotation that we want. In case the rotation of the shaft is wrong, then we need to wire the three phases into a different way. The only thing you have to do is take off two wires of the three, two out of the three, random one you can choose, you just swap, and then the rotation will be right. How can you understand if the rotation is right or wrong? You can see the performance of the pump are far to be the nominal performance. You will see the pump is rotating, but it doesn't produce too much pressure or flow. But that's a little bit harder to check, especially because you have to check on a tap opening, you have still to run the pump. It's a bit tricky. So the simpler way to understand the rotation of the pump is just looking on top of it. There is the cooling fan of the motor. You see, you start the pump, then you stop it, and when the fan is actually slowing down till stopping completely, you can actually see if the rotation is in accordance with the rotation indicator of the plate, or if it is counterwise. And probably the last critical point to care when you install this pump is when you have a VFD driver on top of it. Actually, DAB usually sells this pump with the VFD driver on top, so all the parameters are already set and configured by factory. Sense of rotation will be the right one, the ampere consumption and the nominal value of the pump are already given to the VFD driver, so they work together in accordance. But in case if you buy the pump, a standalone pump, and then you add the variable frequency driver in a second moment, you have to be sure that the parameter and the value that you insert on the driver are in accordance with the value required from the pump. We can always support in this type of operation. It's not that difficult, but it can be a critical point to pay attention.